So on the right hand side, we have a common emitter circuit with a PNP transistor. So we want to find IB. This is IB over there. So to do this, we're going to use this equation. So we're going to say IB is equal to V positive. So V positive, which is 5 volts, minus VEB minus VBB divided by the resistor in between, which is RB. So we're going to have V positive minus VBE VEB. So we're going to have VEB on, and then minus VBB. All of that divided by the resistor in between, which is RB. So we're going to have RB. So IB is equal to, we're just going to substitute the values. So we're going to have 5 volts. So we're going to have 5 minus VEB on, which is 0.6. So we have 0.6, and then minus VBB, which is 1.5 volts. So all of that divided by the resistor in between, which is RB. So 580K, 580,000, and then that is equal to 5 microamperes. So moving on, we have to find IC. So there it is, IC. So to find IC, we have to use this formula. So we have IC is equal to V, multiply that by IB. So this is equal to, so we have this value right here, which is 100. So we're going to have 100 over there, and then we're going to have IB. So IB is 5 microamperes. So we're going to have 5 multiplied by 10 to the power of negative 6, and that is equal to 0.5 milliamperes. So moving on, we have to find IE. So if you look, when you look at this diagram right here, so we have IE coming in, and then we have IB and IC. So we have IE that's coming in, and then it gets split into IB and IC. So which means that IB and IC, when we add IB and IC, both of them equal to IE. So IE is equal to the sum of IB plus IC. So we already have IB, so IB is equal to 5 microamperes plus 0.5 milliamperes. So when we add this together, we get 0.51 milliamperes. So next up, we have to find RC. So where is RC? So this is RC. So to do that, we're going to say that RC is equal to, we're going to use Ohm's law for this one. So we're going to say the voltage divided by the current is equal to RC. So, but which voltage are we going to use? So we have V positive right here, which is 5, and then we have VEC. So we're going to say V positive minus VEC divided by the current IC is equal to RC. So let's write that down. So I'll just write it here. So let's say RC is equal to V positive minus VEC divided by IC. So that will be 5 minus VEC, which is equal to, so VEC is equal to half of V positive. So we're going to have 1/2, and then V positive, which is 5. And then all of that divided by the current IC, which is equal to 0.5 milliamperes. So we're going to have 0.5 multiplied that by 10 to the power of negative 3. And this will give us the value for RC. So RC is equal to 5 kilo ohms. I charge to VCC of 3.3, so we change those values. There we had this figure from 5.2. So what I had to do is to change those values over there. So we're gonna try and calculate the IB, IC, VCE and the power dissipated in the transistor. So we're gonna start with calculating IB. So we're gonna use this equation. So we're gonna say IB is equal to VBB minus VBE on divided by the resistor in between. So that will be RB, that RB. So now we have IB, which is equal to VBB, which is 2 volts. So 2 volts minus VBE, which is 0.7 divided by 430k. So we're gonna have 430,000, and then putting this into a calculator, we get 3.02 microamperes. Moving on, we have to calculate IC. So we can calculate IC using this equation. So IC is equal to B multiply that by IB. So we already have this value, which is 150. So we're going to have IC is equal to 150, multiply that by IB. So IB we found it previously, which is 3.02, multiply that by 10 to the power of -6. So IC is equal to 0.45 milliamperes. Moving on, we have to calculate VCE. So we have to find this value. So to find VCE, we have to say VCC, this value right here, is equal to IC, the value that we just found previously, multiply that by RC plus VCE. So we already have the value for VCC, which is 3.3. So we're going to have a 3.3 is equal to IC, which is 0.45, multiply that by 10 to the power of -3, multiply that by RC. So where's RC? That is 3.2k. So we're going to have 3.2 multiply that by 10 to the power of 3, and then plus VCE. So we can now multiply these two and then take them to the other side. So now VCE is equal to 1.8504 volts. So what else do we have to calculate? So let's see. So we found IB, IC, VCE. Now we have to find the power dissipated in the transistor. So the power dissipated is given by this equation. So we're going to have P transistor is equal to, so we're going to say IC, multiply that by the value, let's see. So we have to multiply that by VCE. So let's say IC multiply that by VCE. So this will be IC is 0.45, multiply that by 10 to the power of -3, and then VCE is equal to 1.8504, and this will give us something like 832.7 microwatt.